All right, so I want to talk about area under the curve, okay? And make sure that we understand, we discussed this briefly on the last section and our last lesson, but I want to make sure that we all have a really good understanding of how this works and everything, okay? One thing I will tell you is this little guy down here is saying is it is helpful to make a sketch. It doesn't have to be super accurate, but like in the example in the homework that we saw where we eliminated 13 as a possibility, that was because in our sketch we could see that the asymptote would have been in the middle of our interval, and of course you have to have continuous function on the interval in order to take the definite integral. Okay, so in this case here, we're asked to find the area of the region enclosed by y equals x squared plus 1, the x-axis, x equals 1, and x equals 2. Okay, so here's the line x equals 1, it's a vertical line. Here's the line x equals 2. And here's the x-axis, and then here is the curve x squared plus 1, y equals x squared plus 1. So that area is what we're trying to find here. Okay? So we've got that. So how are we doing that? Well, as we learned, the integral gives us the area under the curve. So because I want to go from where x equals 1 to x equals 2, that's my lower and upper bound for my integral. And we're taking the integral of x squared plus 1 dx. Okay? So, first of all, I need the antiderivative. What's the antiderivative of x squared? 1/3 x to the third, okay? Or x to the third over 3. And what's the integral of the antiderivative of 1? X, okay? So it's x to the third over 3 plus x. And then here I have to evaluate this from 1 to 2. Okay? So again, a little more review of what we started in the last unit, or last lesson. So now I'm going to be plugging in 2. So I have 2 cubed over 3 plus 2. And then I also plug in 1. I have 1 cubed over 3 plus 1. And I'm going to subtract those. Okay? Remember our f of b minus f of a? Well, here's capital F of 2 minus capital F of 1. That's what we're doing here. So, we now have 8/3, which 8/3 is 2 2/3, plus another 2, that's 4 2/3, minus 1 1/3. So we get 3 1/3 as our total, as our area of the region. Okay? It's not too bad, right? Okay?
It's going to get worse.
It's going to get worse. It's not that bad, okay?
Sideways.
Now, here's something, a little different way of writing something similar. It says, find the area enclosed by one arch of the curve y equals sine of 2x and the x-axis. And this is where you do need to be able to sketch it and figure out some things about the sine curve in order to determine what the interval you need to work on is, okay? Because notice I have question marks here. How much of this are we integrating? By the way, if I took the integral over an entire period of sine that hasn't been shifted up or down at all, what would that equal? 0. Because you'd have an equal amount above the x-axis as you have below the x-axis. And remember, if it's below, it's negative. So that would cancel each other out.
Total area between the curve.
Okay, yeah, now total area, you would split it up and do both of them positive, and we talked about that as well. But here we have sine of 2x, so I'm going to draw my sine curve. The amplitude has not been changed, so it still goes from 1 to -1. What is the period here?
Pi over 2.
Okay, why do you say that?
I don't know. Wait, because it's 2 pi is the whole thing. I don't remember.
2 pi is normal, right?
Yeah. And there's 4.
How do we figure out the period from the equation, guys?
Oh, it's the one. It's 1. It's not changing because there's no thing at the before sign.
That's the amplitude.
And then it's 2. Then you.
Okay? What do we do with this 2, guys?
90 days.
Come on, guys.
Pi over 2.
You do 1/2.
It's something to do with this. This, remember, we called B.
Yeah.
B pi over 4.
Oh, it's yeah,
B
pi
minus
over
A
4.
over 2.
He's right. It's the
The period is the original period, which is 2 pi,
Uh-huh.
divided by B.
Okay.
Okay, and B in this case is 2. Alright? I told you we have a lot of reviewing to do. Okay? So, that means this goes to pi, which means, where's the end of our interval here? Okay, if the whole period goes to pi, then we're going to take,
Pi over 2.
yeah, we're going to go to pi over 2. So now, I know that the interval that I need to go over is from 0 to pi over 2. Okay?
Okay.
So now we need to do the antiderivative. Okay? How are we going to find the antiderivative of sine of 2x?
Negative cosine.
Okay, we know that the integral of sine is negative cosine. Remember, we go this way to take the integral.
That's over 2.
Okay, well, how do you get an over 2?
Because you use the u stuff.
Okay, u substitution, and remember here, if u is linear, it always works according to that pattern where, alright, since it's a linear, the derivative is going to be a constant, 2, so you needed a 2 inside and a half outside, so it always ends up just being the 1/2 times the integral of the sine, so that's negative cosine of 2x. Just like chain rule, the inside function stays the same, okay? So now that we need to evaluate from 0 to pi over 2. Notice I can leave that half until the very end. So 1/2, and in fact, you know what? I'll pull the negative out with it. Okay? So I'll pull this little negative out there with the half, so I don't even have to worry about the negative either while I'm evaluating. Okay? So we have cosine of 2 times pi over 2. So cosine of pi minus cosine of 0. Okay? What's cosine of pi?
1? No.
Negative 1.
-1. What's cosine of 0?
1.
That's 1. So I have negative a half times a negative 2. So the area is just 1. Okay? Now, if I wanted the total area enclosed by one period of the curve, I would find this, but then I would also add the absolute value of the integral from pi over 2 to pi.
Wouldn't it just be the same thing?
It would, because of symmetry. Sine is an odd function, so there's that symmetry. Well, and it's periodic, so there's symmetry in there.
So it'd just be 2.
Yeah, so, yeah, I would have a total area,
So,
in one period.
so you made the interval of pi over 2 0 because every sine wedge like goes under or across the x-axis at pi over 2.
Yeah, because the sine of 2x crosses the x-axis, it starts at 0, and it crosses the x-axis at the end of this first arch at pi over 2.
Just the sine of 2x, not everyone?
Sine of 2x, yeah, because if it were sine of x, then it would go from 0 all the way to pi before it completed that first arch.
What about sine of 4x?
Sine of 4x would be crossing at pi over 4.
And sine of 90x would be crossing at pi over 90.
Actually, yeah.
So forever. Like that.
It's 2 pi, well, it'd be 2 pi divided by whatever this is, would be the whole period. And one arch is half of that period. So, yeah, it would end up being pi over whatever it is. So.